Alrighty, everybody, just making sure that audio works. It looks like it does. And it looks like we're good here. I think, yep, looks good. Okay. Today's lesson is on arcs and finding arc measures and then using arc chords. Okay, I'm not quite sure if I'm gonna do 9.3 as well. I might just do 9.2 and just kind of be done with that. But in the case that I do 9.3, it's because I had extra time to do so. And if I don't do 9.3, it's because I didn't have it. So, okay, so we'll go ahead and start from here. Okay, some vocabulary terms, definitely some of the more important vocabulary terms you gotta remember. You gotta remember the central angle, our minor arc, our major arc, and our semicircles. Okay, you can read exactly what all that is. But the central arc or central angle basically is just an angle that has a angle, well, yeah, an angle at the center. A minor arc is a smaller arc. A major arc is a larger arc. Minors are less than 180, majors are over 180, and semicircles actually equal 180. So make sure that you know those differences. Then we have some, I guess, notation you can call it. Minor arcs are written with 2 letters, major arcs are written in 3 letters. And if you have a central angle here, that then means that the angle for the arc is going to be the same exact measure. So make sure that you know all that stuff. It is also important for you to follow the letters in order, because if you don't, then you're going to mess things up and it's just not going to be good. Okay, there's a difference between major arc ADB, and major arc ABD. These are not the same thing. Okay, so you must make sure that you follow the arc correctly, exactly as it's told. Okay. Next, find the measure of each arc of circle P where RT is a diameter. The good thing here is that we already told that this is a diameter. Okay. And this is good for a couple different reasons. Okay. That means that this arc RT, oh, erase for me. This arc RT, it's a little hard to see there. That's 180 degrees. What that also means is that this arc, TSR in green, is also 180 degrees. Okay, that's what we're going to use to help us here. So we look at RS and the corresponding central angle. Oh, excuse me, guys. The corresponding central angle is RPS, which means that the arc is going to be the exact same as RPS, and that should be pretty easy. It's going to be not 180, 110 degrees. Then here we have to make sure that we are following it correctly, like I said before. So what I like to do is kind of just trace over exactly what I'm looking at. So RTS, start at R, go to T, go to S. Okay, so you're going from everything in the red. And so there's a couple ways we can do about this. We can just say, oh, well, I have everything except for the arc RS, and I know a circle is 360 degrees, so I can just say, well, 360 minus arc RS equals major arc RTS. That's one way you can do it. And then the other way that you could do it is adding up the 2 arcs that make up RTS. You can say RT plus TS equals RTS. And that will work all the same. I find subtracting it here is probably going to be the easiest way to do it. We'll take 360 minus RS, which is 110. And that's going to give me 250 degrees. And that is the correct answer here. Okay. Then move on to the third part, RST. And RST, again, is that major arc, our semicircle, in other words, right there. They're in yellow now. Because it's our major arc and our semicircle, it is just 180 degrees. Okay. Any time that we see a diameter, we know that the arc between the two endpoints is going to be 180 degrees. Make sure that you are aware of that. Okay. Extra example 1, find the measure of each of these arcs. Same thing as before. Go ahead and try it on your own first. All right, come back. And we should get going. AD is 65 degrees. We already have established that. We've already talked about how the central angle corresponds with the arc angle, okay? But that's only for right now. We'll see some other things a little bit later on that doesn't always add up. And I say add up as a figure of speech, not as an actual adding something up, okay? So here we have DAB. DAB is what we want in red. Remember, we do have a diameter here. I'll mark diameter in this yellow here. That means that the both semicircles here are 180. Okay. And if I know what DA is already, and I know that AB is 180 degrees, that should be actually really simple for us. We know that DAB must be equal to DA plus AB. And that's going to give us 65 plus 180. It's going to give us 225. Oopsies. I have it marked wrong in my notes. Okay. Yeah, I'm not sure what I was doing in my notes. Interesting. I believe this is 245. Yeah, that looks good to me. 245. Good. And then we have BDA. BDA is this arc, and that arc. And that should be pretty easy. We already know that it's our semicircle, 180 degrees. Super simple. Here's a key point. And basically it's just telling us that we can identify adjacent arcs. Remember, adjacent just means next to. Okay. And then we have our first postulate, which is actually very similar to the segment addition postulate and the angle addition postulate, just with a little bit of different context. Okay. So basically just did exactly what the previous two examples said, just without really even knowing that there was a postulate about it. Okay. So what we've been doing, it's already now in words. Okay. In this problem, it does not tell us that there's a diameter, so we can't really mark anything preemptively. But let's go ahead and establish, oh, I want to do GE in purple. Okay. GE, I know, is this arc right here, this purple arc. But remember, I want to make sure that I'm trying to find the entire arc, and I need to figure out what pieces I need to add up or anything like that to figure out what that arc is. So that's what I want to go for first. I want to figure out what pieces do I need to add. So I'm going to start with GH. And I'm going to say, well, GH plus HE is going to equal GE. So that must be the what I have to use here. And we have 40 plus 80. And that gives us our 120 for GE. So GE, arc GE is equals 120 degrees. In problems like these, we'll find that they'll kind of correspond, not because necessarily correspond with each other, rather. They'll build off of each other. That's a better word for it. They'll build off of each other. And so we'll see that we have GEF. But if I already know what GE is, then kind of ask yourself, well, what do I need to find then? Right? Because I want GEF. Well, if I already know what GE is, GE plus EF, that's going to give me my GEF. And luckily, I already know these things. I already know what FE is. I already know what GE is. So GE, we said, was 120. And then we have GF, which is 110. That equals GEF. And so I just say, well, 230 equals GEF. Now, of course, if you didn't see that immediately, you could go back and say, well, I know that GH plus HE plus EF equals GEF. Okay, that's perfectly fine. You could do that. Okay. And then last but not least, we need to figure out what GF is. Here, we don't have a diameter to tell us that we have a 180-degree angle anywhere. So we do have to work backwards a little bit, work from 360 to figure out what that GF is. So if we were to show this out right here, GF is the arc that I want. But I know if I take 360 degrees minus the major arc GEF, which is everything that's not GF, that's going to equal our GF here. And I know 360 minus 230 equals GF. Oops. And I know that GF, keep doing that, GF arc equals 30 degrees. Okay. I think it's pretty simple. But I am doing a little bit of extra work just so that everybody can see exactly what my thought process is. Here, go ahead and try it on your own. Okay, after you've tried it on your own, go ahead and come back. Listen up here. First, we're going to establish, I'm going to solve MAC, the measurement of angle of arc AC in green. So I'm going to start at A, go to C, like so. And realize that although this is a word problem, it's kind of useless, really. All that is super fluff. Like the only thing you ever need is to find the indicated arc measures. That's all you need. At least in this kind of problem. Okay. So we know that AC is going to be the addition of AB, arc AB, and arc BC. Well, if I know that inventor and musician are 29 and 108 respectively, I know that those two add up to each other to equal 137, I believe. Let me make sure that is correct. Yep, 137 degrees. Okay, we'll move on to B. B, we'll do it in a different color. We'll do it in, let's do this blue. ACD, so look, we're taking that same arc that we just did and we're adding a little bit more to it. So we know we could just say that this is equal to the arc AC plus the arc CD. And we know that this is going to be 137 plus 83, and that is going to equal to 20 degrees. Next arc, ADC. Okay, again, making sure that you follow exactly where to go. And so there's two ways you can go about this, right? You can add up those three arcs, which would be AE plus ED plus DC, and that of course does equal the measurement of arc ADC. Or what you can do is you can subtract AC from, you guessed it, 360. Okay, if you're a little puzzled on this, right, realize that this is the entire part that I want, right? Everything on the right hand side, so the actor, other, and athlete, that's all I want on the right hand side as part of my arc. And I already took AC before. So it's very easy for me to just say, oh, well, I already know those numbers, so I may as well just use the numbers. But of course, you can just add them. That's perfectly fine as well. But both will give you the same exact answer. AEC to equal 223. And then last but not least, we have the measurement of angle EBD. Start at E, go to B, go all the way to D. Okay, so almost a full rotation, but not quite. Okay. So similar to the last question, or last part, we just take those four lengths or those arcs and add them together, or we just subtract from 360. And I think we both know what is the easier answer here. We're going to take 360, subtract our ED arc, because that's what we don't want. And that's going to equal our EBD arc. So 360 minus 61 equals EBD. And EBD is going to equal 299 degrees. Okay. All should be pretty good, pretty simple. For the most part, kind of. Okay. Just based off the time that I currently have, I have about 14 more minutes to go through two more things. And it looks like I'm just going to stop here at 9.2. It makes no sense to keep going. And we haven't even covered 9.3 yet anyway. So it's all the time in the world. Okay. So we have these two theorems here. These two theorems are actually pretty self-explanatory. Everything that's on the board is exactly what I would say out loud. Theorem 10.3, we can have congruent circles. It's entirely possible if we have the same radius or the same diameter, but realize that they're kind of one and the same in the sense of if radius is 4, then that means diameter is 8, right? Like it's gonna be fine. Don't worry about it. Okay. But we do know that circles are congruent if they have the same radius or diameter. But realize you can find both of them. Then we have 10.4, and this is about congruent central angles. Okay. If the two central angles in the middle, we're not saying the middle, but the two central angles are congruent to each other, then that means that the arcs are congruent to each other. However, there is one small thing I want to add. And I want to say if in the same circle. Oops. Okay, we'll see an example like this in a little bit, but you'll see what I mean. Okay. But it basically just says that if the two central angles are congruent to each other, then the arc lengths are going to be congruent to each other. Okay. There is a difference between arc angle measures, or arc measures rather, and then arc lengths. There is a bit of a difference. Here we have A. Well, A has two 80-degree angles in it inside the exact same circle. And if we're trying to show that these two are congruent, we can confirm that this is congruent, yes. So put your little marks here. Yes, because angles are congruent. And are in the same circle. Okay, yeah, that's pretty good. The second one here, we have a circle inside of another circle, and actually these are concentric circles because they have the exact same center. And let's look at this, right? It shows us that they're both 90 degrees, and that makes sense to us, right? If 90-degree angles are congruent to each other, which they are, then that means that their arcs has to be congruent to each other. And that would almost be good, okay? Not quite here, not quite. Remember that if we have these angles, right? If we have these angles that are in the same circle, then they are going to have the exact same arc length. However, here they are part of two different circles. One is smaller than the other one. Even if it has the same angle, the length of the arc is not the same. So no, the arcs are similar, but not congruent. And you can say not part of the same circle. That's all. That's part of the best way to put it. Okay. And then last but not least, we have C. And this is where it gets a little bit trickier. Okay, you have to make sure you really know your theorems. Here, I know that these two circles are congruent to each other because they have the same radius, right? Because of this right there. Well, if they're the exact same circle, and those exact same circles have 90 degrees as an angle, then it stands to reason that the arcs must be congruent to each other. They must be congruent to each other. And so the way that we would write this is we would say yes. The arcs are congruent because both circles have congruent radii and central angle. And that would be the best way to put it. Okay. Alrighty, y'all. That was our 9.2 lesson for the day. If you have any questions, don't hesitate to ask me in class at an appropriate time. But I'm going to go ahead and let y'all go. But I will talk to you all later.